the dirty secret of the entire security industry. There's been way more vulnerabilities that have gone unexploited than have been exploited. And so most organizations, targets of opportunity that have not actually been targeted, it means they can just be relentless. They can scale the monetization of those attacks. So there's just no place to hide anymore. AI-driven attackers, they're going to be relentless in finding that one misconfigured system, otherwise wonderfully configured cyber hygiene. They'll use that as a launching pad.
If AI has ever made you stop and think, wait, what is happening? You're not alone. I'm Mo, and I'm a security researcher asking the same questions. On Curiouser and Curiouser, we're having open conversations with experts, researchers, and leaders working at the edge of this space, talking through how AI is taking shape, what's shifting, and how people inside the work are thinking about it as it happens. So join us and listen in as the conversation takes shape. Hello, and welcome back to Curiouser and Curiouser. Really excited for today's guest. He's got a really cool background, but as usual, I do not want to skewer it, so I'll let him introduce himself. But today we've got Phil Venables, who is a partner at Ballistic Ventures. So Phil, thank you so much for being on today.
Yeah, pleasure to be here. So just a bit of background about me. So I've been doing cybersecurity for a long time. I initially started as a software engineer many decades ago, but got into doing security in various forms. Was a long-time chief information security officer at Goldman Sachs, then chief operational risk officer and a board director. Spent the past 5 years at Google as the first CISO for Google Cloud and ran security engineering for Google's technical infrastructure. And now, as you said, I'm a partner here at Ballistic Ventures. So we invest in seed and Series A and other early stage cybersecurity companies. We've got a great portfolio across many different segments of cybersecurity. So looking forward to the discussion today.
Yeah, no, I mean, you guys definitely have a very cool portfolio. I mean, I've been on one of your podcasts, and again, all the topics that y'all cover at Ballistics are super cool. And I think you're probably one of the best people suited to talk about this space as well. When we think about AI and everything that AI is doing, especially in the security space, there's just so much noise, and it's really hard to just cut through it. So that's kind of how I want to start, because you've seen this from a lot of places and angles where most people haven't, from Google infrastructure, even some of the advisory boards you've been on. So what's kind of the vantage point that you're seeing for AI security from what is all the noise that people are really just getting bogged down by versus what is actually helpful?
Yeah, so there's, as with any massive technology shift, just like we've seen in prior shifts of internet, mobile, cloud, AI is probably an even more pervasive shift. And when you look at how it impacts security, you've got to unpick it a little bit. So there's the security of AI. And so that's all of the things that security and risk teams are doing to make sure that their organizations, when they deploy AI for business purposes, that they're doing that in safe, secure, regulatory compliant, managed ways that manage all the risks, not just the security risks of those AI deployments. And then you've got the security as delivered by AI, so AI for security. And this you see across everything from software security, security operations, a whole range of different things. And then finally, you've got this broader impact of how AI is affecting the entire security landscape. And I think, as you know, that's what's dominated the headlines for the past few months with the so-called mythos moment, although that's a little bit of a false moment in time because, the quarters and year before that, everybody in the security community was seeing and realizing the profound effect that AI models, particularly models trained for coding, could have on finding vulnerabilities and chaining vulnerabilities together for attacks. So, one element of this is we've got this tidal wave of vulnerabilities that is hitting us because the models are so good at finding vulnerabilities. But that's kind of a short-term thing and a long-term thing. So the short-term thing is quite worrying. Long-term, though, everybody is applying those models to their own code base to find and fix things at rates that we've not seen before. So I think ultimately that could be a good outcome. Secondly, though, which I think is largely going underreported, but for me is more worrying, is the extent to which attackers are now using AI to industrialize what they're doing. So they're attackers have always been resource constrained. And so there's always been more targets that they've not exploited than they have exploited. Now with AI, just like everybody else, they can industrialize and scale and 10x, 100x the volumes of attacks they can put together. So that's going to be the really worrying thing. There's kind of no room and no place for organizations with weak security to hide anymore. And then finally, you've got what you might describe as a quest for authenticity. So you've got fakes, fake workers, fake content, fake brands, all of this other stuff that's driving us as consumers and businesses and governments to want to know what is authentic versus not. So that's kind of a grand tour of everything's going on. So you can see why everything seems to be changing all at once because it actually is.
Yeah. And you touched on a lot of like really, really big things too, from like the attackers being able to catch up in these capabilities really fast. I mean, if you just look very recently, right? Fable 5 came out, and the only difference between Fable 5 and the most recent Mythos release is a couple of safeguards and protections, right? So it's like the very thin line in the sand between an attacker's capabilities and what is actually frontier continues to get smaller and smaller. Even as we continue to see like open source obliterated models start to get used across open source attack platforms. So really like just the ability and the scale that attackers are able to just go and productionize is really, really extreme. On the other side,
and as well, when you look at, Mythos is not the only model with these capabilities. You've got Codex, you've got Gemini, you've got others. And as you point out, over time, more and more of the open models are going to have more of these capabilities. Certainly, when you look at many of the Mythos discovered vulnerabilities, it's been clear after the fact that other lower end models can and did also discover those when you apply them. And so I think anybody that's basing a sense of security on the restrictions in advanced models or the restricted availability of the advanced model is going to be disappointed, because ultimately the cat's out of the bag. Everybody's going to have this capability, to your point.
Yeah. There was like early research done last year, and it continues to be done every time a new model is released, that researchers continuously show that with open source models and the right type of reasoning, right? Being able to like actually walk a model through how to go and do this, you eventually train these open source models to go and perform these Mythos type, Mythos level exploits and these chain of thought and chain of reasoning. So really, it seems like the reasoning layer is the big differentiator that is continuously getting smaller and smaller as these models just get better. And the cost of that is really, again, it's becoming lower and lower. When I looked over the weekend and I saw like Fable was out, my Opus 2 limits were now doubled, right? Because they're like, oh, well, Opus is now going to get cheaper, but that's because Fable's now out and that's the more expensive one. But a couple months ago, we saw that again. Sonnet is now like the cheapest one, where at one time it was the most expensive thing to run. So these costs, especially from producing code, doing reasoning on these really complex problems, it's getting a lot cheaper and easier. But the vulnerability density isn't really going with it. So we're not only just seeing like more code, but we're seeing way more surface area that attackers have to like kind of pick at. And it's just like there's so much to attack now. I'm wondering like our practices, they already don't cover most of these things. Like I've always said that AI is challenging the foundations of the organization security posture, where if your organization did not have that great of a security posture or was not ready in most cases, this is really going to test a lot of those foundational practices. So I guess, does that concern you at all with how fast the threat landscape is growing, how cheap it is to perform these attacks, and how easy it is to scale them?
So on the final point you made, so I agree with that. So Google's developer operations research analysis, this thing called DORA, not to be confused with the European Digital Operational Resiliency Act. So Google's DORA team did a lot of research on this, and the conclusion is kind of obvious in hindsight, but it's good for it to be founded on research, that if you take AI-driven software production into an organization that's got quite unmanaged and chaotic software development life cycles, you're going to get chaos amplified. If you deploy AI-driven or agentic-driven software production into an organization that's got quite a well-controlled software production pipeline and controlled build and testing processes, you get productivity amplified. And so this really does shine a light on the organizations that have yet to get their software production under control with testing and security and quality assurance and all the things that we expect. I think, again, when you come back to the notion of we're going to generate more code with all of this, absolutely the amount of software and the amount of backlog most organizations have in their desire to produce software and new systems is now being met and if not exceeded by the capability of some of the models. So we're going to get an enormous amount more software. I think what is not entirely clear yet is whether in that software there's going to be a greater or lower density of vulnerabilities. So some models are better at producing secure code than others. Most organizations, back to that point of the software development process, are getting better at post-training or prompting models to generate secure code using the libraries they expect and then not bringing in any unauthorized or extraneous third-party libraries. So that whole process is getting better all the time. And I think, if you'd put me on the spot now with a prediction, I think ultimately the models are going to produce a lesser density of vulnerabilities. There's still going to be vulnerabilities, but I don't think we're going to see a higher density of vulnerabilities. I think so. Ultimately, software is going to keep getting better, but to your point, there's going to be a massive amount of software, and so we're going to see bigger attack surfaces. The thing, though, and you're correct to point it out, that we really do need to worry about how attackers use this. I mean, the dirty secret of the entire security industry, as I mentioned before, is that there's been way more vulnerabilities that have gone unexploited than have been exploited. And so most organizations are kind of targets of opportunity that have not actually been targeted. What AI does in terms of the industrialization of attackers, it means they can just be relentless. And so even if they don't get an immediate exploit from even a new vulnerability they've discovered, they can just at low cost just keep hammering away at organizations. They can scale the amount of organizations they target. They can scale the amount of organizations that have a vulnerability that can be subsequently exploited in various ways. They can scale the monetization of those attacks. And so I think that's the real issue here, is not necessarily that we'll discover more vulnerabilities, although that is an issue. The real bigger issue is that this enables attackers to be relentlessly operating at much more significant scale. So there's just no place to hide anymore.
From a security standpoint, this is probably a bad thing, but it's pretty exciting, right? To see like how much this is growing. I think we have to see attack innovation to innovate on defense as well. So the exciting part, I think, about the entirety of AI is while we do have this attack surface that is now, as you said, getting hammered relentlessly, there is the opportunity for teams to innovate in really interesting ways. So, for example, when this first happened, open source repos were getting pounded by PRs and bug fixes that were coming up all the time. And I remember in some cases, these open source programs would close their bug programs, and they would just say, "No, we can't handle all this volume." Well, now we're actually seeing a lot of these maybe go to like auto vulnerability fixes, right? We're seeing some cases where teams are now leveraging AI to help them reduce some of that, like both the cognitive load of so much more noise, but also streamline some of those operational inefficiencies that existed just because it required so much human touch. So I guess what are like some of those exciting parts of programs, and maybe how is AI kind of like lifting up those teams that either didn't have the budget, didn't have the people, maybe didn't have the time to prioritize? How do you feel like it's going to kind of change the landscape for them?
Yeah, so AI is a great kind of democratizer of capability. And so we see this quite a bit where organizations, and I've always thought this, that organizations want to be more secure, and they either can't afford to be or they don't know how to be. And, when they don't know how to be, they can't afford to hire the security team that does help them understand what to do. And then they can't afford to pay for all of the controls. And, there's some very high-end organizations and even some medium organizations that do this really well. But for most organizations, they're in this kind of permanent debt of not being able to deploy enough security capability, whether it's basic cyber hygiene all the way through to other types of more advanced things like continuous red teaming. And now what you see is organizations applying technology from particularly new startups that have built technology based around AI, using AI agents to provide almost infinitely scalable security capabilities. So, I mean, you've probably seen some of the announcements that we did recently. So, for example, Kevin Mandia's new company, Armadin, is basically AI agents for full spectrum red teaming. So most organizations don't have the resources or capability to continuously red team themselves. And now you can do that. Another company we just invested in, a company called Above Security. It's the same thesis, but for insider threats. Most companies would love to have a world-class insider threat program. They generally can't afford to do that in the way they would like. Now you can augment a small team with a large amount of agents to deliver you a world-class program. Another one, exact same thesis, a company we invested in called BreachRx, which is AI and workflow support for managing incidents of various forms and coordinating incident response and incident disclosure. Again, same thing. Everybody would love a world-class multi-domain incident response team. Not everybody can afford that, and not everybody can afford to scale that. Now you can get agents to augment a team to do that, and the same pattern repeats everywhere. But again, stepping back a little bit, though, it's worth reminding ourselves that while AI is going to be a massive boost to security, whether it's software security, operations security, or all the things I just talked about, we've also got to remember that good old-fashioned basic high levels of cyber hygiene type defenses, strong multi-factor authentication, network segmentation, binary authorization, all of those least privilege access controls, many other things implemented relentlessly and implemented well provide a defense to even AI-assisted attackers. The main thing, though, is we've got to implement those at much higher rates of consistency. Because back to that point of AI-driven attackers, they're going to be relentless in finding that one misconfigured system that in your otherwise wonderfully configured cyber hygiene, and that they'll use that as a launching pad. So yeah, I think AI is a tremendous boost, but you don't need AI. You don't only need AI to defend against AI-driven attackers. You have to do all the basic stuff as well.
Yeah, no, that's again a great point, and it's always like back to basics, making sure you have your foundational practices in place. It's just security tech debt, right? If you don't have that fixed, how do you move on with getting a better world-class program? You've kind of got to dot all your I's. But on that, I'd actually like to go back to agents because you brought up the keyword. Everybody's really talking about them, even though it's been around or the concept's been around for a while. It feels like right now, agentic is just like taking flame. And you mentioned augmenting staff with agents, which is the natural progression of how this technology is going and how I think we are envisioning it. So when we look at agents and bringing those into the environment, I think it introduces a lot of unsolved problems that I think we've tried to apply traditional security mechanisms to around like IAM access management and role-based access controls, data loss prevention solutions. But all of these were really designed around the humans, right? So the threat model for an agent is totally different. So when we think about the actor within our organization as an agent, what do you think are kind of the new ways we need to think about that trust layer, and maybe how we need to start reasoning about trust for AI systems that are working autonomously within our environment?
Yeah, so there's a number of ways of looking at this, and it's interesting. We're at the very early days of this, and some of your listeners may be old enough, I suspect not many will be, to remember the early days of the internet. So in the kind of the late 90s, early 2000s, we had a set of technologies for the nascent commercial internet, browsers, web servers, load balancers, all of this type, firewalls, intrusion detection systems. But there wasn't really a set of fixed design patterns of how all those things should be plugged together. And so there was a lot of, uncertainty around how the security models should work. And then over a period of years, the design patterns got locked in, and then we overlaid security onto those design patterns. This feels like exactly the same moment where almost every day somebody's inventing a new design pattern for how agents should communicate, or how agents should interact with resources, or how agents should drive a business workflow or a technology workflow. So I think we're not really going to see a stability in how we think about security until we start seeing some more coalescence of common agentic design patterns for particular problems. And an example of that is exactly on identity. So, should an agent operate under a delegated identity and a delegated set of permissions from a human? Yeah, probably for certain use cases where an agent is acting on your behalf. But for other use cases, an agent should probably have its own permissions in the context of a business workflow. And then maybe for other cases, it should only have an ephemeral identity that's spun up and spun down to deliver a particular subtask in a workflow coordinated by other agents. And every one of those different use cases will have different properties of how you think about the identity, the permissions, the observability. And so all of that is going to be different in every use case. Then overlaid on top of that, we all know agents using models are by definition non-deterministic. So you can ask a model a question 10 times and you might not always get the right answer 10 times. But for deploying agents into business processes, particularly financial transactions, health transactions, other critical infrastructure, those need absolute determinism. And so putting deterministic controls around these non-deterministic agents that aren't in the model itself or in the agent itself, but is in surrounding guardrails that enforce business policies, just like you would enforce business policies around a human's non-deterministic behavior, is what we still have to architect. And again, there's many companies and many solutions and much work from the foundation model companies to look at how you augment agent activity with agent guardrails. And it's kind of very reminiscent. Some of your listeners may be aware of this, very reminiscent of what banks do in high frequency trading systems. They have, they have algorithms, some machine learning derived, some not, but then they always have independent checks like circuit breakers to detect if the agent in modern language is going off the rails, then to kind of block its activity. And so we're going to need the same type of agentic enterprise control plane that we've built for other purposes. And again, this is evolving as we speak because the design patterns are evolving.
Yeah. Like one of the big things that we think about at Alice is a lot about how do you get an environment where agents can kind of play and you can understand? There's this concept of a gym or like an RL gym where we have agents kind of go at scale. They kind of just run their business scenarios and we just observe them and we watch kind of just like an anthill farm. And they do their thing and we recognize the behaviors. We see where it's going out of alignment. But since it's a simulated environment, we're not seeing those same risks happen in a production environment, but we can catch all those really bad behaviors before it actually goes into production. Unfortunately, this is not something I think every organization has, not at any fault for the organization, but because a lot of organizations are actually getting agents from another place, right? So they may be going to a vendor and bringing an agent from outside, kind of almost like bringing in a subcontractor or a contractor to work on one of your teams or a project. So as an AppSec guy, I've always been trained to kind of shift left and move more left. But in this case, there is no left, right? You kind of just have to depend on processes that you have in GRC and your SOC to hope that this new external party in your environment is kind of, playing well with everything else. So I'm wondering, these controls that get embedded for agents that are bringing in, are they really holding up? Are there maybe something else that we need to think about in this runtime layer for agents that we're kind of consuming, not just creating?
Well, it's interesting you kind of use the shift left because, in other spaces I'd advocate, and including this, that you're exactly right. We need to move from shift left, but instead of shift left, we need to shift down into the platform. And so this could be, where agents and in fact any other piece of software should inherit a set of security and other risk mitigating controls from the platforms that they operate within. And that includes the runtime environment, the interfaces to other systems, the libraries, the frameworks that they pick up controls from. And so having that kind of shift down helps you with not just the agents you've developed, but the agents that turn up in your environment from third parties, from, potentially unexpected sources. Because essentially as an enterprise, you want to be able to reason about, to say, for example, let's say I've got a payments gateway or a stock ordering system or some other critical system. I don't want to build the controls only into the agents that may be interacting with that, just in the same way that organizations don't depend on correct human behavior. You have a combination of trained humans, or in this case, trained and well-controlled agents, but you still build tremendous amounts of access control, transactional policies, auditing, observability, and many controls into the resources and systems that are being manipulated by those. And then reasoning about that collective enterprise control plane is what's critical. And that has to be in the, shifting down into the substrate of the organization, the runtime environment. Now, the big question is, what happens to that third party agent that's running in your environment when your controls stop it doing something? How do you signal back to that vendor, hey, I've blocked you because you were doing something crazy? All of these things are yet to be defined, and and that's why this space is so exciting.
Yeah, exactly. And I really like how you put it in shift down, getting lower into the stack where agents are operating. This is kind of fundamental, or it has to happen, especially when, like you said, you have agents that are likely agents within your organization from different vendors, all kind of interacting with each other, right? You don't necessarily control any of those interactions or have much observability on that shift down layer as to like what they're doing, right? So if I bring in an agent from one platform and an agent to another, they happen to interact on a project, then we've got a problem where there's no human, it's just agents, and we don't understand the gravitational risk that one agent has on the other. So being able to report that back, I've said that guardrails are really value adding when you can take the signal from guardrails and turn it back into a flywheel process. Because again, something gets caught by a guardrail, it's not necessarily training the model to get better. It's not training the agent to get better. It's just stopping a bad result from happening. But from there, turning that into signal where you can go and retrain or provide feedback, I think that's really important to be able to say, hey, we caught something bad happening. This is how we would like to see this going forward. This is how you fix it. So I think having that feedback loop or that flywheel cycle embedded within when you work with other vendors or outside is going to be really important in moving forward with shifting down.
No, absolutely. And I think, it's going to be just like all of the other security we've invented and deployed in the past. It's all about how each layer interacts with each other in that kind of feedback loop. So if you've got a resource that is continuously rejecting the attempted behaviors of an agent, then you can't just keep rejecting that. You've got to think what went wrong in the identity and access management process for that agent that I've not appropriately permissioned it, or what went wrong in the enforcement layer that has an agent trying to do something that is against the policy that you want as detected by the resource that for which that kind of rogue access is being attempted, and how all of that ties together. We've spent decades doing that in the kind of human to application to back-end system to other resources. And we're going to have to do the same thing. But I think while it's going to be conceptually similar, I think the nature and the scale, and to your point about kind of anthills, the extent to which we'll see emergent behavior from agent interactions that weren't quite predicted in our policy management systems are going to create some unusual behaviors that we also need to manage and monitor for.
There is this other piece that comes with kind of like all these agents at scale. The platforms that they're originating from or being developed on, we call them foundational models. I think Andreessen called them like a God model, right? Like we have these really big models that do everything. So now we're moving towards a place where we have a couple of these big winners in the model space for enterprise. And a lot of vendors and solutions providers are relying on these models to create these solutions, whether it's providing an agent, providing an MCP layer for this particular platform, or so on. So this concentration kind of reminds me of like these hidden dependencies or like these third-party dependencies that everyone kind of shares, but you don't see it at at the high level because of where they are embedded. So I may be interacting with an agent that may be using OpenAI's technology, and it has the same kind of issues, regardless of what use case I put it in, right? It's just like a basic benchmarking kind of thing. But now we're seeing this at scale with multiple providers, multiple agents. I mean, maybe I'm just like thinking about it wrong or I'm seeing it wrong, but does this problem, like, do you think that this kind of exists at scale, or how AI has been rolling out?
Yeah, well, I think in general, nobody quite knows how it's all going to land, and that's just the nature of that's the nature of the beast we're in at the moment. But I think when you look at first of all, on concentration risks, so we've had concentration risks in multiple industries and technologies for years, and people figure out ways of managing it. You look at the hyperscale cloud providers, never mind the foundation model providers that depend on the hyperscalers to run these things. That's a degree of concentration risk that's managed in various ways by the hyperscalers or by companies figuring out ways to be able to deploy redundantly across multiple cloud and even on-premise infrastructure. So there's ways to deal with that. Then when you think about model dependency, most organizations I've seen over the past few years have been quite careful not to be wholly dependent on one model, mainly because they're always upgrading models anyway, just because they're trying to find the optimally priced model for the problem that they're trying to solve, so that they're not solving every trivial problem with the highest model, and they're making sure they can refer up to a more sophisticated model when they need to. Now, this does point to a dynamic where you see multiple spaces in all of these different vendors that sometimes get accused of just being an LLM wrapper. Is I think, there are some vendors like that, but there's a lot that don't, that they provide a layer to enable companies to have a lot of routing or portability across models. And they pick up a lot of the work of model validation, model testing. And so you see these companies like Rogo AI in investment banking, or Harvey in legal services, all these other companies. And essentially what they provide a set of context, domain specific knowledge, connectors, but also that layer that lets customers dynamically choose which model they're using and then leave it to that service provider to assess and validate whether that model is fit for purpose of what they're doing. And I think a lot more organizations over time are going to, they'll have plenty of use cases where they directly use the models, but they'll also have plenty of use cases where they just say, look, I value that layer of kind of context, connection, knowledge, model validation so much, it's worth me paying a premium to not directly use the underlying models. And I think you'll see various flavors of that. How that shapes out in software security is going to be interesting. So you see plenty of harnesses around the models that help companies do software security. And then you also see plenty of companies that are helping organizations deal with the output of that. So I think there'll be multiple different frameworks of how you do this, but not all organizations are going to want to directly use the models for all things, because they just don't want to deal with all of the testing, the model routing, the updates, all of that kind of stuff.
I completely in agreement. I did recently see a post from Harvey where they enabled Fable 5 within their environment as soon as it was released. However, they released it with a benchmark that showed exactly how well it was performing on their stack. So I think, like you said, these providers, they're not always just a wrapper for AI. They're a context layer, and they provide a layer of context that these foundation model companies don't. So they would rather provide that context layer, allow you to figure out how you want to interact with it. But the consistency of results is kind of what you care about. And that's why you choose the model that makes most sense to you. Obviously, they figure out pricing on their end. And yeah, this one costs more because it costs us more. But otherwise, it's really on you to figure out, okay, well, this is how we want to go for it. And I think that's kind of that context piece, the cost value for the context, and then the provider. All these three things makes it really difficult for leadership to kind of make choices on exactly what they need to be doing. All of these systems get more complex, especially as they get more interconnected, especially when I think even the conversation that you and I just had specifically around having a model, having the context, and figuring out which solution fits best based on all of this. I think there's a lot of, it's almost like the answer is to get everything versus get one thing. And that's not very cost effective. So I'm wondering if there's an easier way to provide leadership and engineering teams overall a more useful picture of like both the solutions that they can pick and the risks that are coming with all of these different things.
Yeah, well, I think in each layer of security, you'll see some companies acting as that context layer over and above the models or what the models deliver to do that. You use the phrase kind of context. One of the key differentiators you see in many companies is they build and deliver a context graph for an organization that builds its knowledge up, that is then used in the use of the model to make better grounded decisions in the context of that organization. You see this in plenty of places. For example, we've got a company called Armor Code that they basically help companies do vulnerability operations. And so they take in all of this information about vulnerabilities that have been discovered by AI models or from traditional sources and build this big graph of what your organization looks like to help you prioritize how to fix things and how to make sense of that. We see similar things in many other spaces. So that context graph is, and the over and above the models is absolutely key. Because ultimately, again, most organizations, they don't just want to use the models for the model's sake. They're using it to solve a business problem. And often the business problem is best solved by augmenting the model, not just using the raw model.
Yeah. So based on this whole conversation, I guess if you had to take away one thing or give something to an organization to take away today, maybe an action that they could take or something that they should think about when they're either making their next purchase or building their next solution, what's like the one key takeaway that you want them to have?
Yeah, I think it's to remember that while all this is new, it's not necessarily new from a first principles perspective. So managing AI risk is about software lifecycle risk. It's about data governance. It's about the operational risk of putting the guardrails and hardrails around behaviors. It's understanding who's got what identity, what resources being. Now, all of that is we've done that for decades in good and bad ways. It's somewhat different and more pressured in an AI and agentic environment, but it's the same basic principles. And I think sometimes in massive moments of change like this, we forget to go back to first principles, or we get dragged into the hype that this is all new and the first principles aren't relevant, which is just not true. So I would say to everybody, just remember, trust your instincts on going back to first principles. And when you think like, why should I let an agent do all these things? The answer is you shouldn't. You should not just rely on the agent behavior model. You should put like controls around it. You should craft its privileges. You should put, access control enforcement in resource games. You've got to do all of that just like we've done for years. So trust your instincts and keep sticking with first principles and everything will be fine.
Cool. As a tech enthusiast, as a longtime software developer and everything, what are you most personally excited about? What would you most be excited to see in the next couple of years with AI? What would you love to see emerge? What's like the thing that gets you? Yeah.
It's not, so it's kind of excited, but not necessarily in a good way, in a more of a curious way. So I think we've not done enough yet to think about the second order effects. So again, I go back to these kind of previous waves of technology. So, when the smartphone really took off in the late 2000s, there was lots of discussions about the risks, but nobody imagined, and they couldn't imagine at that point what the second order risks were. So all of the things that came from what we built on mobile infrastructure, whether it was social media or kind of gig work or all this other stuff, there was loads of risks that came from that. I think we've yet to really develop an understanding of what the second order effects are going to be from this first wave of AI deployment. And this, again, back to that Anthill's comment is, what does it mean? What does a world look like of billions of agents, all with different models and reward functions, interacting in different ways under competitive pressures? Like, who knows what risks are going to emerge from that? I mean, there's some things that could be quite predictable, like when is the first agentic flash crash going to happen when some website posts up an incorrect price and a billion agents descend on it to try and buy and lock in that contract? We're very close to that, I would think. And what's these other second order effects? I think what's going to be fascinating over the next few years that I'm excited to see how we figure out how to manage is just the second order effects of emergent properties coming from a world of trillions of agents wired together in unpredictable ways. It's going to be wild.
Yeah, it is also going to be very fun. I know like I'm in the middle of organizing an agent only conference. So I'm excited to see what kind of talks they put together and stuff, right? So cool, Phil. Thank you so much. Again, it was a real pleasure to have you today. Where can people find you? What do you got going on? What's next?
Yeah. So, on my blog, content out every 2 weeks is philvenables.com, and I'm on X at Phil Venables, and then beginning of next year, there's publishing a book on how to scale security for organizations in a pre and post AI world. So look out for that. That'll be announced on all of the social channels in the coming quarters.
Sweet. Thank you again so much. I'll be looking out for that book for sure, and maybe we'll have you on again to talk about it.
Yeah, cool. That'd be great.
Thank you, Phil. Thanks for your time. And to everybody, stay curious and have a great day.
If this episode helped cut through the noise, like or subscribe so you don't miss what's next. Thanks for spending time with us. Until next time, stay curious.